Howdy. We are gonna do our next section on this chapter of quadratic functions, and specifically, we're gonna solve quadratic functions today. We're gonna work on two methods to help us solve. There's lots of ways to solve quadratic functions, but we're gonna work specifically on two methods today, and those are highlighted in our goals today. The first one to solve quadratic equations. Ooh, found an error. Check that out. Mr. Pout's made an error here. All right, but solve quadratic equations by graphing, and to solve using square roots. All right. So I don't have much of a theme here other than the sandy background, like you're on a beach in warm weather with McDonald's. Yeah, think you know I have the McDonald's M on here? What shape do they form? It looks like a graph of what we do with quadratic functions. The parabola. All right, it's an upside down U. All right, so let's get going into, let's start off with some of the vocabulary. Uh, we've got what a quadratic function is. We've talked about this before, but it's a great review for us here. The ax squared plus bx plus c equals 0. We want to set it equal to 0 for a quadratic function. All right. The root of an equation is a solution of an equation, and in this case, it's found by using the equation. So the root of an equation is going to be the solution. Okay, and again, for these, we're calling them roots because we do have squared terms in a quadratic. So it's essentially like finding the square root. We're finding the root. Okay, the zeros of a function is actually a similar thing. It's where the parabola, so zero function is where the parabola crosses the x-axis. In other words, the y value is 0. That's why it's called the zero of the function. Whenever the y value is 0, that's where it crosses the x-axis. All right. So let's use this. So the first one is graphing. I like graphing. It's a visual. Graphing is always a great way visually to see things. Whoops. Um, so here's our key concepts. Standard form of an equation. Just to recap this, the quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, and a can't be 0. This is called the standard form. So that's the standard form of a quadratic equation when you have it in order like that, in descending order. So one way to solve a quadratic function or equation is to graph it and find where the parabola crosses the x-axis. What's that called again? The zeros of a function. We're finding the zeros of a function, which are also going to be the solutions. Okay, so we're going to see where it crosses the x-axis. So when we graph, let's say we graphed a line and we had this. This is our parabola. X squared minus 4 equals 0. We found some ordered pairs. We found the axis of symmetry, the vertex, and some ordered pairs, and we graphed it. And we see that it crosses at these 2 points. So wherever it crosses the x-axis at 0, those are going to be our ordered pairs of our solutions. So in this case, our x-intercepts or ordered pairs would be 2, 0, and negative 2, 0. Those are our two solutions for this quadratic equation, where x is negative 2 and 2. Okay. So here's our procedure for graphing a quadratic equation. Okay, we've covered this before. We need to review this. First, put the terms in descending order if they aren't already like that, and set the equation equal to 0. So that's important that we set the equation equal to 0. That's part of a quadratic. Find the axis of symmetry. So remember, that's minus b over 2a. That's worth writing down. It's gonna help us, and that's the x value of the axis of symmetry. Substitute the x value back into the original equation to find the vertex. So once you find that x, you can draw our axis of symmetry, but then we're going to use that to find the vertex of the parabola. And we're also going to select two other values on one side of the axis of symmetry and substitute them into the original equation to find the other ordered pairs. When we graph those, we'll graph our parabola. If you just chose to do on one side, then you have to reflect it across the other side. And then find the roots of the parabola by finding where the parabola crosses the x-axis. And this last part If exact roots can't be found, state the consecutive integers between which the roots are lie. So it could be between like 3 and 4. Otherwise, we can also estimate the solution as well. So let's do it. Oh, I thought I had an example here. It must have disappeared. But I want to show you something, I guess. When you do graph them, sometimes you'll have two solutions, like right here. Crosses twice. Sometimes you'll have one solution where just the vertex is on the x-axis, and sometimes you'll have no roots, no solutions, no roots, if it never crosses the um, x-axis. All right. And again, the first one is two solutions, the second one is one solution. Oh, my example must have disappeared. Let's see here. All right, we'll just do this one together. Or maybe we'll do one or two of them together, and then I'll have you do the third one. All right, so let's graph. What are the solutions to each of the equations below? We'll move this up just a slight bit so we have more space here. All right, remember we want to find the axis of symmetry. So I'm going to write this over here, minus b over 2a. So that would be, there's no b value for any of these actually, so it's going to be 0. So minus 0 over 2 times 1. But either way, that's 0. So we know our x value, our vertex, is going to be 0 and something. So 0 squared is 0, and it's going to be minus 16 is negative 16. So I'm going to actually label this going by, let's go by 4s. Negative 4, negative 8, negative 12, negative 16. So if I'm graphing it then, 0, negative 16 is right here. Alright, I'm going to pick two values, 1 and 2. Actually, I'm going to pick two bigger numbers, so I'll do 2 and 4. Alright, 2 is going to be 2 squared minus 16, which is, so 4 minus 16 is negative 12. And then 4 squared, 16 minus 16 would be 0. So I've got 2, 1, 2, and negative 12. And 4 and 0. So I'm going to reflect them across, the same distance across. And here's my parabola. We can see there that we have two roots. So our solutions would be x equals 1, 2, 3, 4, and negative 4. Or the ordered pairs 4, 0, and negative 4, 0. Alright, so let's do this one together as well, and then I'll have you do the last one on your own. So let's find the axis of symmetry. It'd be minus b, so minus 0 over 2a. So it's 0 again. So our axis of symmetry is 0. It's this middle line. Alright, x, y. So I pick 0. When you plug that in, you get 6. So we're going to start at 0, 6. 1, 2, 3, 4, 5, 6. And this is actually going to open upward because it's a positive value up here. So remember, if it was upward, it's a positive value. So I'm going to go by 2, so I have a little bit of space. 2, 4, 6, 8, and so forth. So 0, 6 is right here. Alright, let's plug in a couple other ones. Let's do 1, 2. So 1 squared times 3 is 3, plus 6 is 9. 2 squared is 4. 4 times 3 is 12. That's going to be 18. Ooh, we're going to be off this thing. That's 8, 10, 12, 14. So if I am estimating this, I'll have 1, 9, which will be right over here, and 2, 18, which will be way up here. I'm going to reflect them across. But you should notice something about this this quadratic. It never crosses the x value or the x-axis. So in this case, we have that one there, no solutions. No zeros of the equation. So why don't you pause it, try this one on your own, and then I'll reveal the answer. All right, so when you graph this one, now if you look at the equation, it wasn't set equal to 0, so we had to set it equal to 0 first. All right, so then we ended up getting x squared equals 0, and that ended up being really easy to plug in and find the values. But I found the vertex is 0, and it's 0, 0. So that means right there, there's only one solution, and that's x equals 0. Okay, so that's our solution to this one. Okay, let's move on to their second method, which is using square roots. I'll give you the method right away, how to do it, and we're going to do it. We're going to use it. It's actually just like solving an equation with a square root, with an exponent in it. So number one, it says move all the variables to one side of the equation and all non-variables to the other side by adding the opposite. Isolate the variable completely by dividing by both sides if there's a coefficient of x squared. Take the square root of both sides. So I'm going to put you a tip here, and I would write this. This method here only works with no b value, meaning it'd have to be x, like ax squared, ax squared plus b equals, or sorry, e plus c equals 0. Can't have a b value, otherwise this will not work. But if it doesn't have a b value, this will work nicely. So here's an example. Let's isolate the variable terms. So we have plus 75 to both sides. We have 3x squared equals 75. I'm going to divide by 3, and I get x squared equals 25. Now if you think about this, to get x, x isn't 25, x squared is 25. So we do the opposite of squaring something, which is square rooting it. And that kind of cancels out the square there. So x equals square root is what you do to one side, you have to do to the other, equals 5 and negative 5. Remember, you can have a negative 5 times negative 5 will get you equal to 25 as well. So we do have two answers, 5 and negative 5 in this case. Okay? So that's the basic method of solving using square roots. Alright? So maybe try 3 of them here on your own. I'll do one of them and I'll give you 2 of them to do on your own. I'll choose number 2 because that's kind of like the, well, we'll do number 4. There's no number 4. So I'm going to do the first one. So I'm going to add 36 to both sides to get the x squared value by itself. Plus 36 over here. I get x squared equals 36. Now remember, the inverse of squaring something is square rooting it. So we do that to both sides. And you get x by itself equals 6 and, remember, negative 6. So 2 solutions there. So why don't you try the second one on your own and the third one. And then I'll reveal the answer. Alright, so when I did number 2, you end up getting x squared equals negative 5. And you cannot take the square root of a negative, because there's no number that when you multiply by itself will get you a negative. So we have no solution there. So that's a case where, like, if you would graph it, we'd have no solution. And I believe this was the same one we did here. Or very similar. So when we graph those, there is no solution. But you can also use this method of finding the square roots, and you'll realize there's no solution as well. The last one, though, when you solve it, you get x squared equals 0. And when you square root 0, you just get 0. So there is only one solution for that one, and it's x equals 0. So that's the one where it's going to be at the origin as well. Alright, for the sake of time, I'm going to leave you off with this closing question. I'd like you to think about the error that might have occurred in solving this equation. Okay, so take a look at it, see if you can figure out the error, and then revisit the goals for today. Solving equations using graphing and using square roots. If you can do those 2 things, I think you've accomplished your goal for today. Well, that's it on our first section on solving quadratic equations. Have a great rest of your day.